In this video and the next, we'll have a look at the two basic forms of FET, the MOSFET and the FET. However, you should note that there are many variations on these basic themes by different manufacturers, and even devices which are hybrids between FETs and BJTs and try to capture the advantages of both. We don't have time to look at all these different devices, and that's left as an exercise for you. MOSFET stands for Metal Oxide Semiconductor, and its construction is shown on the screen. The channel is made by various means, depending on whether the device is a depletion or an enhancement type, or a P or N type. You can read about all the various types in any good textbook on electronics. It is connected at both ends, one connection to the source and the other to the drain. Above the channel is an insulator. On a standard silicon substrate, this insulator is usually silicon dioxide, SiO2, often made by heating a silicon in the presence of oxygen. We are most familiar with SiO2 in its non-crystalline form as glass. The simplicity with which a good insulator can be fabricated on silicon is one reason why it's such a fine material for making this type of electronics. On top of the insulator is deposited the metal gate electrode. There is no direct connection between the gate electrode and the main device material. They are separated by the silicon dioxide. When a voltage is placed on the gate of a device, it generates an electric field which attracts or repels charge carriers, i.e. electrons or holes, from or to the channel, and it hence controls the channel conduction, as explained in the previous videos. Because there is no direct connection between the gate and the channel, the MOSFET has a very high input resistance, i.e. gate resistance. In fact, the gate looks just like a capacitor, and the presence of this capacitance ultimately controls the speed of the device. The high input impedance has a disadvantage though. It makes the device sensitive to static electricity, and a static discharge can blow a hole in a sensitive insulating silicon dioxide layer and destroy the device. Precautions against this include wearing an earthed anti-static wristband, using an earthed soldering iron, and storing and assembling MOSFET circuits in and on a special anti-static conducting material. MOSFETs make excellent low-loss switches for power and digital electronics, and also amplifier input sections when very high impedances are required.